systems by graphing. We had talked about parallel and perpendicular lines, so those were two lines. We talked about graphing lines, so now we're kind of going to put those two ideas together, and we're going to have two lines in the same graph. And in order to solve a system is two equations that represent the same scenario, same situation, and their solution is the place where the two lines are equal. So that would be the point that they cross at. And obviously in order to see where they cross, we're going to graph them. Although we will find out as we go along that graphing is one method for solving systems of equations. It could possibly be the most method that's the most time consuming, but if it's the method that works the best for you, then feel free to use that. So like I said, in order to solve a system, we want to see where they cross. In order to see where they cross, we got to put both points on the graph at the same time. So I'm going to start with graphing the first graph, y equals 2x minus 2. My y-intercept is negative 2. My slope is 2, so I'm going to go up 2, right 1, sorry. Up 2, right 1. If I needed to, I could go down 2 and right 1 as well. Just depends, how much graph space you have, how big you want to make your graph. And I will draw the line that connects those points as straight as I possibly can. Ooh, not so good at first, but it'll work. I think you'll get the idea. So next what I want to do is graph the second line on the same coordinate plane and see if the two lines cross. And if they do, where do they cross? We would expect that graphing two lines on the same coordinate plane, that they would cross. The only time they wouldn't is if they were parallel. All right, so the second line has a y-intercept of positive 1. So that's why I went ahead and put a dot at 1 on the y-axis. And my slope is a half. So that means I'm going to rise 1, run 2. Ooh, interesting. They share that point. Rise 1, run 2. We might already have the solution. And since we do, because we found out that they have a point in common, I'm going to connect those two lines. And they do cross each other. They happen to cross each other at this point right here. And to finish and find our solution, we would just name what that point is. To get to that point where they cross, we have to move 2 places to the right and 2 up, so that becomes the point 2, 2. The solution to this system is 2, 2. Basically what that means, that's the one and only point that they have in common. It's the one point where if I were to plug the point 2, 2 into both equations, it would give me true statements for both lines. For example, if I put a 2 in for y into equation number 1 and a 2 in for x, and do this math, does 2 equal 2 times 2 is 4 minus 2? Does 2 equal 4 minus 2? Sure it does. 2 equals 2. So 2, 2 works in the first equation. What if I plugged 2, 2 into the second equation? Does 2 equal half of 2 plus 1? Well, what is half of 2? Half of 2 is a 1. Does 1 plus 1 equal 2? Sure, 1 plus 1 is 2. So 2, 2 works in both equations and it makes true statements. And it just so happens to be the place where the 2 points cross on the coordinate plane. 2, 2 is the solution. Let's try the second graph, or the second system, I should say. Equation number 1 has a y-intercept of positive 2, a slope of 1/3. So I'm going to rise 1, run 3, and I could keep doing that, but I'm going to run into my equation. I'm going to, instead of rising 1, right 3, I'm going to go down 1 and go left 3. And we'll do that one more time. I have the space, so just in case. Since we don't have the second equation on the graph right now, we really don't know if it's far enough or not far enough. So it's a little bit better to have more than to have not enough. Okay, now I'm going to graph the second equation. The second equation starts all the way down here at negative 5. 1, 2, 3, 4, 5. I think I'm in the right spot. Okay, and my slope is -2. So -2 actually has two meanings. I could go down 2 and right 1, but as you can tell, I'm running out of room. I could also go up 2 and to the left 1. And since I don't have the space to go down 2 and my line's above it, my line is above my y-intercept, I probably do want to go up so that I can get back up there by this second line. So I'm going to go up 2, left 1. Haven't run into my line yet. Up 2, left 1. Still haven't run into my first line. Now I'm going to up 2, left 1, and I will run into my other line right there. So that must be the solution to that system. And that just so happens to be the point 1, 2, -3, +1. The nice thing about this and other things in algebra is that we always have a way to check our solution. So let's see if this works. Whoops. Oh, I forget I can erase. So y equals 1/3 x plus 2. Y is a 1. X is a -3 plus 2. Is this equal? 1/3 times -3 is going to end up being a -1. -1 plus 2 is a +1. So yeah, it does work in the first equation. Let's see if it works in the second equation. Y in this point is a 1, so I'm going to change it to a 1. -2 times x. Well, x in the point that I found to be the solution is a -3. Does 1 equal -2 times -3 minus 5? -2 times -3 is a 6. 6 minus 5 is 1. So yep, 1 equals 1. That tells me that -3, 1 works in both equations. So that must be the solution to my system. Okay, we're still going to solve systems by graphing, but I do want to show you a couple scenarios here. And I'm not going to necessarily go and give the equations right away, but let's say I'm got my coordinate plane here, nice and straight, as always. And I draw my first line, and it kind of ends up like this. And I draw my second line, and I find out, hey, wait a second. Whoops, yeah. Straight as always. Wait a second. These two lines are the same line. They lie on top of each other. How do I determine which point is the solution? Because there's many points that are the solutions. So this particular system would have many solutions. The first two systems, only had one solution. This one has many. That could happen. Okay, now another situation. Let's say I was given my two equations, whatever they might be, and my graphs ended up like this. And I'll try to do this as best as possible. Okay, so I have another pair of lines graphed. I didn't give you the equations for these. I just want to show you that this could happen. So let's say you've graphed your system. The lines don't cross. They're parallel. They never cross. The point of solving a system is to find out where the two lines cross. If they never cross, then there is no solution. And that's what you would say. So your possibilities are that they'll cross in one point, they'll never cross, or that they'll cross many times because they're the same line.